Welcome back everybody, I'm Dave and today's video is about the unit circle. So this is a complete walkthrough with the unit circle, how to use it, how does it link to exact values, more importantly how can we apply it to exam style questions. I will use a mixture of like degrees and radians in this, so you can use it for any course, whether that's AP course, pre-calc, IB, A-level. So I'll break the video into these following sections, just defining all parts of the unit circle. How do we turn and how do we actually read from the unit circle? What reference angles and how can we apply them? Some exam style questions, and then finally link the unit circle to the actual trigonometry graphs. So let's get started. Okay, let's go ahead and define some of the key elements of the unit circle. So first of all, the radius of this circle is 1. That's given away by the name, the unit circle. We also start by counting all degrees or angles from this point here that I've circled in yellow. That is known as like 0 degrees here. As we rotate anti-clockwise, we will reach this axis here, which is 90 degrees. Therefore, if we keep going, we'll have 180 and then 270 degrees. Now, if you're working in radians, you should know what those are. That would be pi over 2, that would be pi, and this would be 3 pi over 2. So depending on what course you're doing, you may be working in radians or degrees. We want to talk about quadrants now. So if we just think about this as being a graph, and I'll just draw the origin here, we've got 4 main quadrants here. This is quadrant 1, this is quadrant 2, 3, and 4. Now this is important because when we're doing questions, we may be given what's called a domain, and it might give us like a certain quadrant to work in. So it's important that we label them in that particular fashion, going sort of anti-clockwise. Based on that, then, if we knew like the quadrants 1, 2, 3, 4, you should also remember this sort of acronym, ASTC. Now, what that stands for is all trig functions are positive in this quadrant here. Only sine is positive in this one, only tan is positive in this one, and only cos is positive. So again, when we're doing some questions in a moment, I will refer to ASTC, and it follows the quadrants 1, 2, 3, 4. The last thing we're going to talk about just on this particular page is that we must always remember that the horizontal axis is related to cos theta. Okay, that is super important. Horizontal is cos. Vertical, the y-axis in this sense, is always going to be related to sine theta. Okay, so always remember that. Horizontal cos, vertical is sine. Okay, so imagine putting yourself somewhere on the circumference of this circle. So let's just put a little cross here. Now, if we join the origin up with that point, what we've done is we've created a line that has length 1. We spoke about that earlier. This is why it's called the unit circle. Now, I just want you to imagine drawing a triangle down here that has a right angle and an angle here, theta. Right now, we have a triangle that has a hypotenuse of 1, right, with an angle here. Now, if a hypotenuse of 1 means then that if you're working with these right-angled trig formulae, which SOHCAHTOA, the ones I'm interested in are the ones with h, so this one and this one. Now, h is going to be 1 in all cases, right, because it's always going to be 1 as we move around the circle, that h will always remain as 1. So that means then that if you're trying to figure out the opposite side of this triangle, so let's just put OP for opposite side, we could use sine, right? Because we've said that the opposite side here is equal to sine theta times h. But sine theta times h will be sine theta times 1, because 1 will always be the hypotenuse. So that means then that the opposite side of this triangle will actually always be just whatever the value of sine theta is. And then we can apply that exact same principle for the adjacent side. So let's just go back to this one here. And let's say I'll just put AD for adjacent. How would we find the adjacent? We could go over to cos. And we'll say that, well, the adjacent side is cos theta times h. But h is 1 again. So therefore, the adjacent side is just going to be, so we'll just write that down. The adjacent side is just cos theta times h. But h is 1. So it's just cos theta. So that means the adjacent side of this triangle is cos theta. And therefore, then the coordinate of this point on the circle, therefore, can be now represented by cos theta, comma, sine theta. So that will be true for any point on this circle as we move around, that coordinate will be cos theta, sine theta.
Oh! Righty then.
Okay, so let's just briefly talk about turning in the correct direction. So default is basically anti-clockwise. That is basically if the angle is positive, then we will turn anti-clockwise from the starting position. So what does that look like? Let's look at 90 degrees. If we start here and we have to move 90 degrees anti-clockwise, we will moving to the top here. Therefore, then that is a 90-degree turn. The coordinate at the top there is, if you look at where we are on the graph, it's sort of at the origin, which is 0, but then we're also at the top of the circle, which is 1. Remember, this distance is 1 because it's the radius of the circle. If we just go around another 90 degrees, so let's say we turned 180 degrees, we're going to be at this position over here on the left. So that will have a coordinate of -1, 0, because we have moved -1 to the left of the origin, and we are neither up or down on the y-axis, so that would be 0. We might as well do this one here, which is the 270-degree turn. So if we keep turning, this is at 270. This has coordinate 0, -1. And if we keep going around back to the starting position, so that's a turn of 360, this will have coordinate 1, 0. Okay, so those are the sort of 4 main extremities in terms of 0 and 1. So what happens if we have to move, let's say, 60 degrees, right? What do we do there? Well, we start off at the same position here, 0, and we will rotate 60 degrees. Now, 60 degrees will be somewhere, up here. And what we will need to do now is we will join a line up with the origin, and this is now 60 degrees in here. Okay, and then we draw a line down, and we have a triangle. Now, in the next section, I'm going to talk about why the exact values are so important here, because we're going to have to decipher the 60 degrees. 270, that is one we've already seen. If we rotated 270 degrees all the way around, we will be here. So we already have the coordinate of this. So it's more about what happens when it isn't those extremities, 0, 90, 180, or 270. So we'll see that in the next section. Let's just talk briefly about what happens if it is negative. Now, that is just a movement in the clockwise direction. So if we start here and we move -90, it means that we are going to move -90 this way. So you will be at this location here. And that same goes for, let's say we had -45. So we'll start here and we move -45. Okay. Now, when we're at this point on the unit circle, we still have to draw a line connecting to the center, but this is 45 degrees in here now. Okay. And we would still need to draw a triangle that relates to the x-axis here, where the right angle will be on it. Now, we're going to talk all about how to solve those in just one moment. Okay, so that is the difference between clockwise and anti-clockwise when we're moving around the unit circle. Okay, so in this next set of problems, I'm going to be using exact values and reference angles. In some courses, you will need to remember this, like the IB or IGCSE, other courses that may be given to you. So I have made a video on how to remember all of these values, so please watch that video, and I think you'll find it quite helpful. Other than that, we'll get started. So first question is basically, what is sine pi over 3? Now, you can just do this without the unit circle, but I want to draw it on for you. So you can see when we get onto the more complicated ones how this all comes together. So 60 degrees is here. Sine pi over 3 is sine of 60. And what it means is because sine is related to the vertical height, remember. So otherwise it's asking us, what is the vertical height of sine 60? And that is √3/2. Okay, and you can refer back to the exact values grid. Let's color this here. Sine of 60 is √3/2. Okay, so like I said, we didn't actually need the unit circle to help us do that, but we will in just a moment. So for example here, what is sine 3 pi over 2? So we've got a value that's greater than 90. So if we rotate our way round, this is 270 degrees. Okay, it's pi over 2, which is 90 times 3. So it's going to rotate all the way around to here. And we are at this location here. Now, the value of that, well, that coordinate is 0, -1. Now, remember, sine is vertical. We're interested in the vertical coordinate, and that is this value here. So the answer to this question is going to be simply -1. Let's go over to the third one over to here now. So that's sine of 2 pi over 3. Now let's just convert that into degrees for those people working in degrees. Okay, sine 120. Okay, so if we start off on the right-hand side here, and we need to rotate 120 degrees, that means we are going to go past 90, there's 90, and 120 will be in this quadrant. So it doesn't really matter where you put the marker, as long as it's in the right quadrant. So now I'm going to join that marker up with the center, and I'm going to draw a triangle. Now, always remember to draw your right angle on the x-axis. That is important. Okay, so this angle here was 120. Now, I want you to always think about what the angle would be inside the triangle here. So inside the triangle, this would be 60. Now that is what we call our reference angle. Because we have a table up here that has all of the values, exact values, between 0 and 90, that's what we're going to use. So we're interested in sine of 60, and we've actually just already used that one, is root 3 over 2. So if we go back over to the diagram here, what I want you to understand is the height of this triangle here is root 3 over 2, right? So I'm going to say then that I think that the value of sine 2 pi over 3 is the same as the value of sine 60. Now, that is, in this case, true, but we still should just double check the quadrants, remember? A stands for all trig functions in that quadrant are positive. S stands for only sine functions in that quadrant are positive. So basically that is true then. So the value of this is going to come out to be positive root 3 over 2. In a moment, you're going to see that that won't always be the case, right? But we can visually see that it is vertically like up from 0. Therefore, it's going to be a positive value. Okay, let's have a look at some more examples. 3 pi over 4. Well, pi over 4 is 45. 45 times 3 is 135. So this is the same as saying cos of 135, right? Right, so that's 90 round to here. And then we won't have to go all the way because 135, like I said, it's just purely like visualization, but we do need to remain in the correct quadrant. So I'm going to draw this line here to the center. I'm going to draw my triangle. Remember, sticking to my rule that the right angle always stays on the x-axis. So now this angle is 135, and this angle here is 45. So my reference angle, the one I'm really interested in, is the 45, right? Because I'm going to refer to my exact values grid for 45. So let's go up and have a look. Now we're dealing with cos. So cos of 45, right, let's use this pink again. So 45, but this time cos, so is 1 over root 2, right? So 1 over root 2. So that means then, because we're dealing with cos, it is the horizontal that I'm interested in. So I'm saying that this horizontal distance here is 1 over root 2, okay? But look at the quadrant that we're in. So AS, right? So we're in S, which means only sine is positive in this quadrant. That means all other trig functions will be negative. So that means then that this value is negative actually. And we can see that as well. So if I just go over to this laser pointer here, you can just see visually that if you were here and you move to the left, then you're moving into the negative territory. So that value is negative 1 over root 2. So I'm just going to go up to here and sort of write down the answer here. The answer to this is negative 1 over root 2. And remember, that's the same as 135. Okay, let's try this again. But this time we have a negative, so we're going to have to move clockwise. So this time the angle is pi over 3, so that's 60 times 2. That's minus 120. So we've got cos of minus 120 that we need to do into 120, which is somewhere in this quadrant. So always the same, join it up to the center, make your right angle with the x-axis, and that angle there is 120. Remember, we went in the negative direction, so that's actually moving clockwise. So let's try and figure out our reference angle. That's 60. So our reference angle is 60. So it's to do with cos. So let's go up to our table here. We're looking at 60 and we're looking at cos, so it's a half, right? We have a half. That means then that if we're dealing with cos, the horizontal length here is 1/2. But again, just like the previous one, we can actually see it's to the left of 0. So it's going to be negative half. But I'll prove that through the quadrant example. Look, A, S, T, C. A good way of remembering that is all students take calculus. And we are in this quadrant 3. And it says here clearly that only tan is positive. So sine and cos will be negative. And I can see that visually that we are to the left and down. So both sine and cos are negative. So the answer to this is negative 1/2. Right, so minus 1/2. And that's another question done. Let's try this one. Cos 5 pi over 3, right? So anyone who's not working in radians, pi over 3 is 60. 60 times 5 is 300. Right, so we're doing cos of 300, and it's positive, so we're going to be moving positive round. Now, I haven't given myself much room here, but let's try. So where's 300? Well, that's 90, 180, 270, so we're going to be in this quadrant down here. Put a marker, it's 300 degrees. Okay, don't forget that that angle was 300. That wasn't a lie, we moved around. But let's have a look at what's left with the reference angle. So that means then if we drew this line connecting to the x-axis, that would be 60. So my reference angle is 60 this time. So let's go ahead and have a look. We're dealing with cos 60. We just had that on the previous one, so I know that's a half. So that means that this horizontal length here of this triangle is 1/2. And I can see it's to the right of the origin, so I know it's positive half. If you wanted to double check the quadrant, we're in this one here. C, all students take calculus. Remember quadrant 1, 2, 3, 4. And it says that cos is positive. So the answer to this is 1/2. 1/2. Okay. Got one more here to do with tan. Oh yeah, so tan's a little bit different because remember horizontal is cos and vertical is sine. So what do we do here? Well, I would just say just figure out the angle here for tan. Okay, so pi over 3 is 60. 60 times 2 is 120. So we'll basically essentially work out what tan 120 is. Just use the unit circle to help you with the quadrants. So if we start at 0 here and we have to move to 120, we are in this quadrant, and that is 120. Okay, leaving a reference angle of 60. There we go. So basically, we just want to figure out what tan 60 is. So if I go to my exact values grids, tan 60, you can see over to the right here is root 3, right? So it's root 3, but is it positive or negative root 3? So I would say, first of all, let's just write down that we think it's root 3, and we check the quadrant. So A, S. Now, only sine's positive. Very important. That means that all the other trig functions are negative. So the answer to this is negative root 3. So that's how I deal with tan. Okay, so I have two exam-style questions here. One is just to evaluate a trig expression, and the other is slightly different, where we're given a value that cos is equal to, and we have to figure out where that is in the domain. So let's just start with part A. So it says evaluate 1 minus cos squared pi over 6. For those of you working in degrees, pi over 6 is 30. So don't actually need the unit circle for this. If we know what cos 30 is, well, let's just draw it on so we can just see. Okay, so that's 30. And then cos of 30 going over to our exact values, cos 30 root 3 over 2. Okay, so that means that this horizontal distance here was root 3 over 2. And the expression that we had to evaluate was 1 minus cos squared. So 1 minus, well, cos of 30 was root 3 over 2. We just said that. And it says squared. So just remember that this is a squared function. And that would result in 1 minus, well, root 3 is 3, and 2 times 2 is 4. So 1 minus 3/4, leaving us with 1/4. Okay. Part B, for what values does cos theta equal minus half? So let's do this slightly differently. This time, like, where is cos theta is minus half? Well, cos is to do with horizontal. So minus half is here, right? Now, this time, I'm going to draw a vertical line down here. And what's going to happen here is I have to figure out like what this measure of turn is round to this point. So because this will create a triangle. So this here, got to figure out what this measure of turn is, right? But what we're going to do is we're kind of going to work backwards and say, well, let's use a reference angle. Let's use phi here. Okay, let's use a reference angle. What angle gives us a horizontal distance of half. So we can do inverse cos. So if I use that here, if I said that if cos theta equaled a half, I know it says minus half, but I'm just looking at the sort of pure magnitude of the value here. So here, this horizontal distance, the value of that is a half, but it is in the negative side, but the actual length of it is 1/2. So if I just go ahead and say, well, when is cos theta equal to a half, I can do inverse cos of the left-hand side in inverse cos of the right-hand side. And this is where, you'll need to use your exact values, is if we go over to here and we want to know when does inverse cos equal half, there it is. So that's going to be at 60 degrees, right? So that means that on this graph, the value here in the phi would be 60, right? But the thing is that isn't quite right, is it? Because we need to figure out that turn round to that point. So that turn would be 120 degrees, right? And it would seem like we might have answered the question there. But if you look very carefully, it does say that the domain can run from minus pi, that's minus 180, to 180. So that means then the window that we're looking for is moving 180 round to here, and I would say that I have found that first angle, but we must stop, and then we have to go the other way. So there's going to be a second triangle here, and the second triangle would be down here. So sorry, it's a little bit messy there. That means that we will be able to turn this way, also 120, but that will be minus 120. Okay, so we've got two possible answers, which would result in that value equaling minus a half. So I would say the two answers are a positive 120 and a negative 120. And if you had to write that in radians, then and negative 2 pi over 3. There we go. And that's the end of those exam questions. Okay, so in the final part of this video, I would just want to link the unit circle to the actual trig graphs. I feel like it's doing a little bit injustice if I don't. So if you see here on the left, I have a unit circle, and this is going to be representing cos. Okay, so have a look at the graph, the cos graph on the right. I'm going to show you this cool animation of how we link the unit circle to the cos graph. Okay, and the second graph I have here is sine. And last but not least, the graph for tangent. Let me know how you get on in the comments below. Don't forget to like and subscribe to the channel. See you next time.